And example 3 covers cube roots. So main difference here is you'll notice that instead of just having that square root symbol, there's a 3 here, which tells us that we're looking for the cube root. So my suggestion, I've made a little cheat sheet for myself. I have the perfect cubes written out because these are not as commonly known to you guys as the square root. So it's a really helpful tool while we're working through this. Basically, like the cube root of 64 is 4 because 4 times 4 times 4, 4 multiplied 3 times is equal to 64. So it's similar to square roots, but now we're multiplying 3 times. So we're going to do letter A here, which asks us to simplify the expression the cube root of negative 128. So I still want to pull out the greatest perfect cube factor, similar to what we did before. So I'm going to break it up by writing the cube root of negative 64 times 2. And remember, 64 is one of my perfect cubes, so that works. That factor I can pull out. Now I'm just going to kind of break it apart so that I have negative 64, the cube root of negative 64 times the cube root of 2. And then I'm going to simplify what I can, which is the cube root of negative 64 is negative 4 multiplied by the cubed root of 2. That one cannot be simplified any further. All right, the next problem that we have is similar, but now we're introducing variables. So just like when we were taking and simplifying square roots with variables, we needed to have even exponents. Now that we're working with cube roots, we want to have exponents that are multiples of 3. So similar to what I did in the first one, I'm going to go ahead and break this apart. I have the cubed root of 125 multiplied by the cubed root. Now I'm going to break apart x to the 7th power because I want it to be a multiple of 3. So the biggest multiple of 3 that I have is x to the 6th multiplied by the cube root of just regular old x, or x to the 1st power. So now I can go ahead and simplify again the cube root of 125. That's where this little cheat sheet comes in handy. But the cube root of 125 is 5. The cube root of x to the 6th power is x squared. And then all that I have left over, this is going to be multiplied by the cube root of x. All right, we're still working with cube roots here, but in letter C, I now have a quotient. So we're going to use our knowledge from the quotient rule in the previous example. So my first step, I'm going to go ahead and break this up. I have the cube root of y over the cube root of 216. There's nothing I can really do with y, but I can simplify the cube root of 216. That comes out to be exactly 6. So 6 will be in the denominator, and then I still have the cube root of y in the numerator. All right, this last one here has quite a bit going on. We've got different variables, some numbers, and some exponents. So I'll take it slow, take it step by step. My first step is I have on top the cube root, and I'm going to just go ahead and go straight to breaking this up. I have the cube root of 8, that is a perfect cube, times the cube root. I'm going to break apart x to the 4th power so that it's a multiple of 3. And now I just have the cube root of x left over. So the cube root of 8x to the 4th becomes the cube root of 8 times the cube root of x to the 3rd times the cube root of x. That is all going to be over the cube root of 27 times the cube root of y to the 3rd. And I don't need to break up y to the 3rd because the exponent is already a multiple of 3. So now I'm going to simplify. The cube root of 8 is 2. The cube root of x to the 3rd is x. And then all that I have left on top is the cube root of x. In the denominator, both of these will simplify. The cube root of 27 is 3. And the cube root of y to the 3rd is y. So this here is my final answer. All right, here are 4 problems for you guys to try on your own. So go ahead and click pause on the video, write these problems down, give them a try, and then I'm going to go ahead and go through on how I would solve them. So for number 9, we have the cube root of 54. So coming back to my perfect cubes, I'm going to see what number is a factor, what perfect cube is a factor of 54, and that's going to be 27. So I will break this apart so that I have the cube root of 27 times the cube root of 2. And that is because 27 times 2 is equal to 54. Now to simplify, the cube root of 27 is 3 multiplied by the cube root of 2. That stays the same. We can't simplify it further. Which perfect cube is a factor of 16? And that one's going to be 8. So I'm going to rewrite this as the cube root of 8 times the cube root of 2. I'm going to run out of space there. But then I need to look at x to the 4th. So remember that I want my exponent to have a power that's a multiple of 3. So I'm going to do times the cube root of x to the 3rd times the cube root of x. It's a little bit scrunched there at the end. So now I'm going to go ahead and simplify what I can. So the cube root of 8 can be simplified, and the cube root of x to the 3rd can be simplified fully. So the cube root of 8 is 2. The cube root of x to the 3rd is x. So 2x can be simplified and brought down into my final answer. What's left over goes back inside of the cubed root. So it's multiplied by the cube root of 2x. And this would be my final answer. All right, number 11, I just noticed that I was missing the fraction symbol for this quotient. Hopefully you caught that, but this is supposed to be the cube root of a over negative 27. So again, if we break this up, the cube root of a over the cube root of negative 27, and a can't simplify, so we just leave that as is. In the denominator, the cube root of negative 27 is negative 3. For this last one, the cube root of 25c to the 7th d to the 3rd over 64, we will go ahead and break everything apart. Now, the cube root of 25 can't be simplified, so that's just going to stay as is, and that's okay. Then we have c to the 7th, so I'm going to pull out c to the 6th so I can simplify that fully. And then I have the cube root of c left over times the cube root of d to the 3rd. And all of that will be over the cube root of 64. So hopefully I don't run out of space here. I'm going to simplify what I can. The cube root of c to the 6th is c squared. The cube root of d to the 3rd is d. And then in my denominator, the cube root of 64 is 4. Now what I have left over will just be multiplied on the outside here, and that is the cube root of 25 and c were the only ones that were left over. So anything that can be simplified fully, you can take the cube root of it, you're going to simplify and put out in front. What's left over gets put at the end there.